In this lesson, we're going to take a look at how to write equations in slope-intercept form. Now, slope-intercept form, as far as linear functions is concerned, is the most basic type that we use. It isn't necessarily the easiest, but it is the most common. Slope-intercept form is any function or equation that takes on the appearance of y equals mx plus b. Now, in here we have four different items. The x and y are called variables. The m and b are technically called parameters because they have specific roles that they play in the function. M is the item that acts as the slope. B is the item that acts in place of the y-intercept. So if we can get an equation with these two pieces of information, slope written as a fraction or as a whole number, which is a fraction divided by 1, and the y-intercept, some value when x is 0, then we have the information necessary to be able to write the equation. For instance, if we take a look at the information given, a slope of 2 and a y-intercept of a -3/2, I can simply begin with my equation, y equals mx plus b, and then substitute in values. I'm told that the slope is 2 and that the y-intercept is a -3.5. This lets me write y equals 2x plus a -3.5 or y equals 2x minus 3.1/2. Same thing on our next. If I know that my slope is 0 and my y-intercept is 6 3/4, I can again begin with y equals mx plus b and begin substituting in values. Y equals 0x plus 6 3/4. Simplifying this, 0 times x is 0 and it disappears. I simply have y equals 6 3/4. So again, a reminder, if we have an equation with y only, that is a horizontal line when graphed at the value given. If we have x only, then it comes out to be a vertical line at the x value that is given. So we're able to write the equations if we have this information. The same should be true if we are shown a graph. We should be able to pull out the pieces. In this first graph, we have our line that cuts across the field, and what we need to do is find a couple of points that would be useful in helping us write our equation. We can see a point when we have a perfect intersection of our line with the graphing grid. So as indicated, we do see such an intersection here at 2, -4. Then I need to find another one because 2 points make a straight line, and I get that out at 6, 2. Now, using the fact that slope is change of y divided by change of x, I have to ask, how do I change from this -4 to this +2? And the answer is I go up 6. Next, my change of x, how do I change from 2 to 6? And the answer is that I increase by 4. Simplifying the fraction, I come out with a slope of 3/2. Now, I use my other information, y equals mx plus b, to write an equation to solve for my y-intercept since I can't see it on the graph. Well, either of the points that are included that I have found become valid x and y values. So, if I use the first point, I have -4 equals 3/2 times 2 plus b. If I take this and simplify, that's -4 equals 3 plus b. Subtracting the 3, I get b equals a -7. So my equation here comes out being y equals 3/2 x minus 7. What about my next graph that I see? Again, I'm searching for places of perfect intersection, and I get one at 0, 2. And then as I search out another, I see it right here at the location 5, -2. Now, again, my slope is change of y divided by change of x. Change of y, I go from +2 to -2, that's down 4. Change of x, I go from 0 to 5. So my slope is a -4/5. Now, in this graph, because I do see the location of the intersection, or the crossing of the y-axis, I know right away that my y-intercept is 2. That comes from here. So my equation comes out being y equals -4/5 x plus 2. Now what if we don't have a graph? What if we just have the points? Well, written in function notation here, I see f of 2 equals 8. Recalling function notation, that is the coordinate 2, 8. And then I have f of 0 equals 1, so that's the coordinate 0, 1. I can use this same way I did from a graph. What is my change of y? How do I move from 8 to 1? That's down 7. And then change of x, how I move from 2 to 0? That is down 2. So my slope is -7 divided by -2, which is simply 7/2. Because I do have this point of 0, 1, I know my b value, so I get y equals 7/2 x plus 1. Next function, I have the points 3, 6.5, and 8, -3.5. So first, what's my change of y? How do I move from a +6.5 to -3.5? And that is by going down 10. Next, how do I move from 3 to 8? And that is by going right 5. So my slope is -10/5, which is -2. Now, I need to find my y-intercept. So I'm going to say 6.5 equals a -2 times 3 plus b. So 6.5 equals a -6 plus b. And solving for b by adding 6, I got 12.5 equals b. That means that my end equation, y equals a -2x plus 12.5. So if we have different pieces of information, we can go through and find our slope and find our y-intercept to be able to write an equation that we'll be able to use in modeling different items. So let's look at one such modeling. Hydroelectric power generation in the year 2007 was 248 terawatt hours in the United States. In 2012, that number had risen to 277 terawatt hours. Write a function, we're going to call it P of t, to model the hydroelectric generation for t years after 2007. What's the hydroelectric power generation in 2016 according to the model, and what would it have been in 2000? So if we take these items, we have to look at our equations, or our information. P of t is what we're calling our function. So instead of y or f of x, we're doing P of t, power based on time. Next, we are told that t is years after 2007. So if I have the year 2007, that's been 0 years, and I have 248 terawatt hours. In 2012, which is 5 years after 2007, that number had increased to 277 terawatt hours. So I can use this to help find my slope. M equals change of y divided by change of x. My change of y will be 277 minus 248. My change of x will be 5 minus 0. That 5 minus 0 is much easier to do, so that's just 5. My numerator comes out to be an increase of 29 terawatt hours. So Since I can't simplify this fraction, that is my slope. Now I do have my y-intercept, or my p of t intercept, so my equation comes out to be p of t equals 29/5 t plus 248. Now my follow-up questions: what will the generation be in 2016? Well, how many years is that since 2007? And that will be 9 years. So I go p of 9 equals 29/5 times 9 plus the 248. Simplifying this, we come out with 302 terawatt hours. What was the generation in 2000? Well, what year is 2000 compared to 2007? That will be a -7 years. So now I have 29/5 times a -7 plus 248. Because we are working with a negative, this number will go down. And when we do that computation, we come out with, in the year 2000, there should have been 207 4/10 terawatt hours of hydroelectricity generated in the United States. So we can use two pieces of information in order to generate points and then find enough information to model an equation. A lot of items in the world and in life do come out to be at least close to linear. So even though it might not be perfect, this does help us to make models and make predictions for the future.